Hi, everyone. I hope you're having a good day. Today is Wednesday, and this is Monika Wahi. I'm just starting the chat a little early so you can get in. Um, I'm actually kind of not ready, so I'm kind of opening some files here. So I probably shouldn't open this day. Well, I'll open this set and we can look at it. Um, so today I wanted to talk to you about box plots and percentiles um, because I've been doing some work on my YouTube channel, and obviously I'm a data scientist, and YouTube has really cool analytics. So one of the things I was noticing is people all over the place seem to want to know about box plots and percentiles. And they look really simple and cute, but they're actually not that easy to make. They weren't that easy to teach back when I taught them. So I thought I'd do a little live stream where I can kind of show you different ways to not only make a box plot, but to teach how to make them. And if anybody has any questions about interpretation, I'm happy to talk about interpretation. They're very, I wouldn't want to say easy to interpret. They're useful, and it takes you a while. You have to see them often, and then you get used to knowing what they mean. So, so I'm happy to talk about interpretation, but the main thing that I'm here to do is sort of show you different ways you can make box plots, uh, depending on what you're doing, whether you're actually just analyzing somebody's data or your data, or you're trying to teach somebody how to analyze data, or you're trying to teach yourself, or you're trying to maybe make a blog post explaining what you did. And so I'm going to actually demonstrate a few different things from my experience in box plot land. Um, well, I'm going to show you a lot in R. You know, I love R and I'm always using R. But I'm also going to show you other things besides just R. So, but R is cool. So of course I'm going to show you R. So let me give you one more minute, maybe a few more people join, and then I'll start my little shtick. And this live stream is going to have files associated with it. I'll post them on GitHub. I always like to go back and update the description from my live streams because I'm always going to all these websites and stuff. That way, if you're watching it now and you want to you want the code I'm going to show you and stuff, just come back and there'll be a link to my GitHub. All right. Well, now it's time to start the live stream. My name is Monika Wahi, and I'm a data scientist, but I also, teach statistics. I kind of teach a lot of different things. I say I teach. I mean, I'm a consultant. I just do data science. But I'm always. It always seems like I'm teaching it, even when I'm doing consulting. It seems because I'm always working with people because I'm an epidemiologist. I'm always working with like physicians and nurses and so it seems like I'm always teaching because they don't know how to do it because I'm an epidemiologist. That's our job. So I'm supposed to know how to do it. I guess they like it working with me because I always teach and stuff. But anyway, so the purpose of this live stream was to just show you how to make box plots. Now, if you wonder what one is or all that, you can watch my video on how to make them and what percentiles mean and everything. But first, let me just start by sharing my screen and talking to you about the data set that I'm going to use here. Um, and I actually stole it from my last live stream. This is the data set we're going to use. We're actually just going to use the staffed beds here. And let me show you where I got it. This is Massachusetts data sets. And just to remind you where I got it, actually, I should have gone there first. Let me show you this other web page. Uh, that's what I probably should have showed you first. Um, where is it? Chrome tab. I'm not that good at this stream yet. Okay, this website here is called ahd.com, American Hospital Directory. And if you go on here under free national stats, and I explain these are statistics, they're just on the web. And why? Because they're public. Here I went to Massachusetts. I live in Massachusetts, so I'm kind of used to the hospitals here and the cities here and the geography. So I went and I basically just turned this page into data. And then now I'm going to show you that data. I probably should have done that. Explain that first. Um, and here's the data. It's data about hospitals, and so you have the hospital name, and then the city. Like I'm in Boston, and the staff beds. That's how many beds are actually staffed. That they actually have staff on that are open. Because you'll see some of these hospitals, if you come to Boston, they're really big, but they may have a lot of outpatient going on and may not have staff beds. So and then this is total discharges, patient days, and gross revenue. We're going to be working with the staffed beds. That's what I'm going to use for the box plot. But you're welcome to download this data set and try the box plot with different things. All right, let's see here. So, all right, so why don't I start by, why don't we go to R? So I put that data set in R. So let's go to R. Okay, so let me see if this looks good in there. Okay. So so that data set is a CSV that I read into R. And you can see here, here's my read CSV um Massachusetts Hospital demo set. And again, I'll put this on GitHub. I'm calling it HOSP A. Well, you know why I'm calling it HOSP. I always, if you take my LinkedIn learning courses, you know I always do this A when I start with a data set because I like to increment the suffix as I transform it. So let's look at what's in HOSP A. Let's see how it comes. Yeah, we know what it looks like, right? Here's a name and all right. Okay, and again, here's the column names, the fields in the data set here there. Okay, so let's just remember what a box plot is. It's actually I probably should have shown you one here. I'll bring up one of these, one of the ones that I'm gonna show here. Basic. Let's bring up one of these. We're gonna make this one later. This is just one of them that we're doing. Um, Let me see here. So I'm gonna let's see here. Here it is. Okay, so here's one of the box plots. Actually, let me see if I can make it a little bit bigger. Okay, see this box plot? Now, the, it's a box, and this top bar, this top, I guess it's called a bar, is at the 75th percentile of a quantitative variable, like staff beds, right? So this would be at the 75th percentile. The bottom of the box part is at the 25th percentile. And this middle part is at the median, the 50th percentile. And then you've got the minimum and then the maximum at the top. And you've got the tail. So it's actually a box whisker plot, or I guess those are whiskers. These are tails and these are whiskers. They're not animals. I don't even know why I'm going into this. But anyway, that's what we're trying to make as a box plot. Okay. And then I'm going to show you now how. So the first thing you would probably realize is that if you were going to draw one, um, you could draw that box. You could just draw it. But the problem is you'd have to know those things I was telling you, the 75th percentile, the 25th percentile, the median, the minimum, and the maximum. And if you want to do something fancy with the outliers or do all that, you can do that extra, but you would at least need to know those things. All right. So if you're good at R, you think, okay, I can just read this into R and I can just take that staff beds column, and there's got to be a command in R that will tell me the percentiles. And actually, you're right. There is a command in R, and it's called quantile, right? But I'll cut you to the chase. If you read in that data set and you try to do quantile on it, it's not going to work. And I'll tell you why. It's because for whatever reason, see this class command? The staffed beds variable reads in like a character. Maybe there's something in there. I mean, I looked at it and I couldn't figure out why I read in like a character, but I didn't see any characters in it, but this is not unusual. If you do data science, this is like so normal. So I was like, well, I just want to do this demonstration. Maybe I can just use this as numeric wrapper and, get out of having to do anything about it. because if you do as numeric, you'll see they'll just list them, and these are the staff beds. And you see there's this NA. Well, one of them must have been blank. Now, remember where this data comes from is I think it's quarterly data. The hospitals have to report to Medicare, that's our public insurance for elders, what's up with them, like how many staff beds they have. And this American Hospital Directory makes some of that data available. Like they clean it up and make some of it available online. So who knows what happened? Maybe they didn't submit it or whatever. They probably have staff beds. Like you see all these zeros here. They probably have beds too, and it's just bad data. But I just was trying to do a demonstration. But anyway, so we get these NAs, and that's what R uses. If you're a SAS user, you're using a period here. That's what they use for null. So you can't just do quantile on as numeric staff and then NA remove equals true. I tried that, but I think I am having an order of operation problem. SAS users will know what this means, because if you do things in the wrong order in SAS, you get things like this where you thought you removed something but you didn't remove it because you got to put it in the right order because of the way SAS processes. So I thought, well, if it's acting like SAS, I'm going to have an R answer. So my R answer was to I'm just trying to demonstrate this, was to just pull out a vector and clean it up. So this is me pulling out hospital A staff beds as a vector. I called it bedvec, of course, underscore A. So when I did that, I still got NAs, but this is now a vector. This isn't in the data set anymore. It's a vector. And it's a vector. How many things does it have in it? I put a length at 72. Okay. But we still need to get rid of that NA. So here's the command to get rid of the NA. I made bedvec B. So you see how I do this? That's how I don't run out of names. And then the length of B is C71. I got rid of it. Okay, now I can do, what was I even doing, right? I was doing the quantile. This is the quantile command. Now we can do it on that vector. And you can see, here's the minimum. Here's the 25th percentile. Here's the median. And here's the 75th. And here's the 100, right? So now is a good time for me to show you what would happen if you were trying to just demonstrate to a class like drawing or whatever, how to do this. Like they got the quantile, so let's draw a box plot. I just find that a lot of times I'm having to demonstrate how to draw one by hand, even though I'm teaching R, you know what I mean? So I'm just going to show you how I do that. And I'm going to show you in Paint, because it's like everybody seems to have Paint except for people who have Macs, I think. I don't know why this opens so wide, but let me then share my screen with Paint up. Here's Paint. Okay, so I can just draw on this, and I'm not a very good drawer. But what I'm going to do is look back at my percentiles, and the first thing I'm going to do is just get ready to draw something, right? So we know if we're going to make a box plot, we're going to need like a Y and X axis. So I'm just making this as like, this is going to be the Y axis right here. And I already know that this is going to be 0, right? Yeah, that's good. Okay. But what am I going to put at the top? Well, I'm going to sneak back here and look at my maximum. My maximum is 852. So I'm going to make the top, I'm going to cheat and make the top 900. That's how you do it on the fly here. Okay, so then what do I do? Before I do the rest of the box, I'm going to make a few lines here. Like, so this one's halfway, right? So I'll go and I'll say 450. But it's hard to graph like that. So I'm going to make a few more. And remember, you're just demonstrating and you just want it to be right and you don't want to take all day. So here I could probably do like maybe 400s here and 500 and 6, 7, 8, 9. And this is 450, 400, 300, 200. Oops. 100. You can put your hand on Control Z a lot. And you can put also just some notes in here, like this was 400. Here we have 300. 800. Just to give them an orientation. All right. So so that was my maximum was 852. But usually what I start drawing to make sure it doesn't turn into a hot mess, is I start with the 75th percentile, which was 270 from our quantiles. So let me go back and so where was what did I just say? It was 270. That just seems like really down there. Okay, so 270 would be down here somewhere. So you're gonna need to make this kind of out here. So I'm making just a line here. So I start by making this line. If you're clever, you could make the whole box. Maybe we could do that. Well, that's the top of the box. The bottom of the box is going to be at the 25th percentile, which is 67.5. So that's really down here, like about here. So if you're good with the box, you could have just done this. Like, well, maybe I'll just do it now. Have the box here. Whoops, did I do that wrong? Yeah, I did wrong. I didn't grab the box. There we go. Okay, yeah, I guess it's a little easier. Okay, so now we've got the box part. We need to put in the median across. Just look over there, 145. And that's really close to down here. So you can already see it's skewed, right? Those of you who are used to looking at box plots, you know that this is skewed. Where was the minimum and maximum? Well, the max was 852 and the minimum was 0, remember, because we had some probably bad values. So here's 0. Let's make another line here. We'll go from 0 to 852, which is up here. It's too bad. I could put color this over there, but I should have probably put that in there first. Or I could put them separate. Maybe it makes it a little clearer. I can go down to 0. And then up to 852. You can draw the whiskers on. And of course, I wouldn't keep this. I'll keep it for you as an example of this demonstration, but I wouldn't keep it this way. Let me save it as a demonstration. I wouldn't keep it this way for the class, but I would just show them that this is how let me just say this. I can't talk and say it at the same time. That this is roughly how you draw it. Because if you've got a class, they're going to have to draw it on something if they're trying to draw it. Like if you're not, it depends on how you make the assignment. If your assignment is do it in R or do it in some software, then you don't have to draw it. Okay, and I will show you an example of some online software you can use, which I actually used in my class where because if you're making them draw it and you're making them calculate all these things by hand, you can't really give them an n of 100, right? And so I gave them small n's to calculate by hand and make box plots by hand. But I'll show you another thing that I used so that they could use more numbers and see bigger box plots of bigger numbers. But okay, but for now, let's just go back to R. Let's assume that you don't need to do it by hand. You can just teach it on here. So where we left off is we had done our quantile, and then one of the things since we're doing quantile here, in case you wanted other percentiles or other probabilities, these are the default ones because they know I'm making a box plot, I guess. If you wanted other ones, here's a great example. So this is it without any arguments. If you want other probabilities, like I pretended I wanted 9.95 and 0.05, like the 5 percentile and the 95th percentile, you just make the C here, this combine 0.05, and you can put as many in here as you want, and it'll tell you the probabilities for it. So watch this. I'll do this, and it'll tell me. Here they are. So even the 95th percentile is pretty high. Okay, so what have we done so far? Well, first we looked at our data, which was StaffedBeds, and then we ran the quantiles of it because we wanted to see where these things were in case we wanted to make a box plot by hand or demonstrate it. All right, but now we don't want to do it by hand because obviously it's very messy. Let's do it in R. Okay, so we've got our bed vec. So base R has a box plot function, which I'll just run here. Okay, there it is. There. So this is a box plot. So you can see it kind of looks like ours, but because we had to go up here, but like the zeros here, I don't know, it's a little misleading. But you can edit this box plot. You can put titles and stuff on it. But I don't because I'm an R snob. R snobs go, "Oh, are you using base R for that plot? You should be using a ggplot too." So that's what I'm saying. You should be using ggplot too. And there's 101 reasons why. Among them is that it's just makes sexier plots. But I will make an argument for base R. And I'll tell you why. Because I often want a quick and dirty box plot like I just showed you. Because I'm just trying to figure out the distribution of it. I'm just in a hurry. You know, what I'm going to show you now, it's like your box plot. It's like your box plot is the sewing machine that's always out. And the ggplot 2 is kind of like the serger. Like you have to get it out and set it up and thread it up and get it going. But it makes something fancy. So where I'm going to show you just we could just spend the whole time in ggplot 2, but here's me running the library and getting it into okay. So I find it easier, it's up to you, but I find it easier to use ggplot2 with data sets than vectors. So what I did was I sort of remade our vector into our data set. So I started with hosp A, and I just converted StaffedBeds to a variable called StaffedBeds underscore n. Okay, so now that, and it's so mad about this. And how many rows does this have? Well, it's 72, just like the vector had 72 items. Okay, now I'm gonna get rid of that whole record with the NA in it. So this is me creating hospital B and dropping that record with the NA in it. And how do you know I dropped it? Well, let's look at the N row. See, I dropped it one way. And also you can just look at the field by here and you can see. All right. So if you want to just get a box plot out of ggplot2, you need to, if you're using data, you need to declare the data, and you need to declare the AES, the X under the AES command. I guess it's a set of command. And you've got to add a plus and call the geom underscore box plot. That's how you get the box plot. So let's run this ggplot. Actually, I got to run the whole thing, right? Yeah, here we go. Okay, so you see, and you saw me drawing the box plots like in a vertical orientation. So I don't feel good when I see them horizontally, and I don't know why. I think in healthcare, if you read journals, most of the time you're going to see them in the vertical orientation, but there's nothing that's right. It's just that the first thing is this freaked me out, and I was like, oh, I don't like it. But that's the most basic. Now you see, make it pretty. See, I can go crazy with it. Here, I'm making it pink. It's pretty. Putting some labels on it, and I do the coordinate flip, right? That way, I've got my night, and you'll notice my labels are mixed up, right? The X label is staff beds, but then when you flip it, the coordinates flip. And then I put theme classics. So now we're gonna get something beautiful here. Beautiful. Look at that. So much more gorgeous. So this is way better than the thing I was drawing, right? And I don't know about this command. I'm gonna have to look to see how they decide on the outliers and stuff. But they're putting the outliers in. It's nicer. Now, definitely, when I publish, I definitely just totally deck out these ggplot2s. I just make them gorgeous. I'm a snob. I just spend my whole day on that figure. But you can't do that if you're just looking at distributions. You've got to get your work done. So just don't get stuck in ggplot2 with this. All right. However, it is easy to do. So I'm going to stick on ggplot2 just for a second because It is so sexy. Like, what if I wanted to compare box plots? Because that's what you're always doing. Well, the problem is there weren't any sort of natural groups in that data set. So I decided to just pick out a few cities I just happen to know have a bunch of hospitals in it and just say, okay, we'll compare cities. But it's kind of not a fair comparison because I included Springfield and you'll see in the data set they only have two hospitals. You really should be making a box plot out of that. But so I created this vector called keep cities. I thought, oh, this will be a good little data sciencey thing. So this is my vector, keep cities, Boston, Worcester, and Springfield. Yeah, you really pronounce that Worcester. I had to learn about it. Um, okay, so you know that hospital B has what 71 rows. We're gonna use a subset command and we're gonna make it so hosp city, that's one of the fields, is in, don't you like that? In keep cities. This is like my favorite trick. You can do it in SAS, SAS is an in too. You can do it in data steps, okay? So that way you can change the vector and you can change the cities. Like the first I just put Boston, Worcester, and then I put Springfield. I thought, oh, I like these three little boxes that it produces, but probably shouldn't have made the Springfield one. Okay, so we're gonna make the subsetted data set hosp C. See how I don't run out, and then we'll look at the rows. We only have 15, right? Actually, let's just look at hosp C. Here, yeah, here it is. And see, there's only two from Springfield. There's only four from Worcester too. You probably shouldn't be doing this. So this is illegal. Don't tell anybody who did this. All right. So the reason I did it, this illegal thing, was mainly to show you this sexy ggplot 2. You know that it can get you in so much trouble. But the main thing that I changed about this data is, besides changing it to hosp C now is the data, is I added a Y, which is the hosp city. Now, these happen to be just written out here. Often cities are just like they'll have some code, and then a code would come out and be ugly, and so that's a whole nother thing you have to deal with the ggplot too. And then I wanted it colorful, and I knew it would find three cities, so I put three colors out here. That's the main difference between this one and this one. So let's just run it and is that gorgeous? See, and then there's Boston, Springfield, Worcester, and staffed beds. That just doesn't even seem right, right? Because I think Boston should have. I don't. Well, it was the pandemic, and I don't even know what's going on anymore. We had field hospitals and everything. I don't even know if they're in there. Who knows what's going on? All right, the healthcare system crashed. Sorry, are still running, but the healthcare system crashed. I thought I better look at hospital C. So I decided I was going to write it out as a CSV here. So I did that, and then now let's actually go look at that um, data set here. I'm gonna bring up hospital C from what I exported here. Okay, let me go and share it my screen with you. Here's hospital C. Okay, it's a CSV, so it comes a little ugly here. We have our staff beds N at the end here. Now, as you can see, was it Springfield this year? 735. That was that why Springfield was way up there. But I thought Boston, I don't know, everything is different. The data change, right? So I'm going to highlight this and I'm going to do data sort and I'm going to sort it by hosp city here. That way we're going to get all these staff beds up here. I guess I can use this one. For Boston right here. Because I wanted to show you something else. And that is that I actually gave this data set to my class who was doing things by hand. They weren't using R. But I wanted to show them how to deal with the box plot with a lot of values in it that they made themselves. So I'm going to copy these values and I'm going to paste them into this calculator, this online calculator that I wouldn't use in like a real life journal, but it's great to use with students. Okay, and it's on this Alcula website, and they seem to have I'm going to stop sharing. We'll go to that. They seem to have other calculators, but um, let's see here. But this is the only one I found use for. So this is this Alcula, and this thing has been here a long time. I don't know, but if you come here, you find this, and you can choose a sample or population, and you'd have to read their doco as to what they're doing exactly. And also, even when I was teaching how to make these by hand, I found out there's two different ways to calculate the 75th and 25th percentile by hand. So I had to deal with that and tell the students I was just doing this certain way, and I don't know. This is a lot more complicated than it looks. Okay, so I'm going to just enter this data. I just pasted it. It says enter comma separated data, but let's see if it'll handle it if it's not comma separated. Yeah, it did it. Okay, see that? And it says the population is 9. This was just the Boston one. And here's the, let's see here. Maximum was 804. That must have been the maximum on here. Yeah, it sure was. Um, and so it put the um, commas in there. And one thing you could, if you make the class do this, what I did was I had them sample. I had them take a systematic sample and make the box plot, and then everybody did it. And I said, "Ha! We did a simulation. Let's look at the population box plot, for the whole Massachusetts, and see how our different simulations, your different samples compare it." I mean, it was kind of a fun little thing, but they had a little trouble saving it. You have to kind of go right click and save image as, which I did for you. So you'll get, I'll show you this image on my GitHub. But anyway, and the link to this is in the description of this. So let me go back here. All right. So I just went over a whole bunch of stuff really quickly. First, I went over, what do you need to make a box plot by hand? And the answer is at least the minimum, maximum, 25th, 75th, and 50th percentiles. Then I said, okay, well, how do you demonstrate drawing one? And I showed you using paint to draw one. Then I showed you two different ways of using R to make a box plot. And then finally, I showed you this calculator that you can use online to make a box plot. And so I haven't gotten any chat questions yet. Does anybody have any questions about box plots? Because I guess I'm talking about all this. Why would you even do one? Well, the main reason is you want to see the distribution of your data. You will notice that if you think about staffed beds, okay, there's going to be, and you saw all those zeros in our data. So our data were like left skewed. I always think light on the left is left skewed. So they were left skewed. And or maybe they were right skewed. I don't know. I can't remember. Let's look at the box plot. Actually, they were pretty normal now. But I've noticed that like one of the things that's always skewed is length of stay. If you ever get hospital length of stays, like every single person who gets checked in and checked out, most of the time it's like 1 or 2 days. But like long COVID, every once in a while it's a long time, and so that's always skewed data. Now, if you've got normally distributed data, where the median and the mean are on top of each other, you can do certain statistics then, and you can't do them if it's skewed. And so, what are the strategies? You can use different statistics, but you could also take often a log of the skewed data. You can take a log of each of the values, and then you might get a normal distribution. But what you're doing is you're making box plots the whole time to help you see where the distribution is. So so this was just kind of short. I just wanted to check in and show you a few things, and then I'll put up in the description. I'll put all the links, and I'll put up a GitHub so you can go get the code. And if you're here, thank you for joining me. Everybody's very quiet today. Nobody's got any questions. I really appreciate you coming to my channel. Even if you're not here to make a box plot, if you would look around and see anything you like, it'd be great. Please like it or subscribe or both. I'm trying to put up more stuff, so let's see how I do. Well, thanks for joining me and Wednesday afternoon, and I hope you have a good rest of your week.